Hello, good morning, good afternoon, and good evening, physics students. Ay,
Ayan, STEM
STEM
003
003
students.
students.
Welcome to our General Physics 1
Medyo
classes.
nalo-loading tayo kasi 12:43 na.
12:43 na
At
lang.
wala pa tayong
Madaling
kain.
araw.
Oh.
Madaling araw. Okay, Module 4 is about describing motion of a projectile. Favorite mo to, di ba?
Yes, of course.
Favorite mo yan,
Favorite ko
Tito.
yan. Kayang-kaya ko yan ng
Ayan.
bongga.
STEM 3, Module 4, and our objectives for this topic
Okay, we have described motion of a projectile at a given point on its trajectory.
And second is to solve problems involving projectile
Diba?
motion.
Hindi nawawala yung solved problems
Siyempre
talaga.
Okay, syempre,
Let's start with
i-define
this.
muna natin kung ano ang projectile. It is a body which is given an initial velocity and then allowed to move under the influence of
Yes.
gravity only. Once a projectile is released, it will trace a curvilinear or nonlinear path called trajectory. Ayan. So, ibig sabihin, kapag projectile, yan yung nafo-form mo kapag hinagis mo ang isang bagay. Nagkakaroon siya ng trajectory na tinatawag.
Nating
Curvilinear.
Okay.
Ayan.
Projectile motion naman is a combination of horizontal motion with constant velocity and vertical motion with constant velocity. Take note, acceleration. Take note, Ma'am Tintin, na kapag sinabi kasi nating projectile, it is a combination of vertical and horizontal motion.
Yes.
Mamaya makikita nila yan sa ating mga figures.
Yes. Okay. Next. Ayan, explain muna natin ang projectile motion. So, projectile motion, gaya ng sinabi kanina, meron tayong dalawa. It is composed of horizontal and vertical. Kapag horizontal, motion at constant velocity. Ibig sabihin, hindi yan pwedeng magbago kasi nga constant.
And when we say vertical motion naman, motion like freely falling object. Bakit freely falling? Kasi nga, nanggaling siya sa taas. From the word
so
vertical.
mag-fall siya dahil meron tayong gravity.
Mamaya, makikita natin yan ng bonggang-bongga.
Yes. Ayan. Next. Okay, yan yung sinasabi natin kanina. Projectile motion, ibig sabihin, meron siyang curvilinear or meron siyang projectile. For example, dito, kapag naghagis ka, yan, makikita natin yung mafu-form niya. At lahat ng ifo-fall natin ay pupunta pababa. It is because hinihila siya ng tinatawag nating gravity.
Hindi pwedeng mangyayari na kapag nagbato ka ng isang bagay pataas, ay papataas siya ng dire-diretso. Bababa at bababa yan, kahit nagaanong mo pa yan inihagis pataas. Tama, Ma'am Tintin? Ay, take note, Ma'am Tintin, di ba nasabi natin kanina, kapag sinabi natin projectile motion, combination yan ng horizontal at saka vertical. Okay, titignan mo yung
so, tingnan nyo.
Pataas, meron siyang pataas.
Meron siyang pataas. Ayan, meron siyang pagbaba. Okay.
Maliwanag yun.
Ayan. So, here are the examples of real-life examples of projectile. Ayan. So, kung mapapansin mo, unahin natin yung unang picture, golf. Nag-golf siya. So, kapag tinamaan niya yung bola, lalayo siya, tama? Pero, bababa pa rin yung bola. It is because of gravity.
Next one is, famous yan, basketball. Di ba kapag sinut nila yung ball, ma'am, okay, o kaya pinasa yung bola, okay, bababa at bababa yan kapag walang nagka-catch.
Yes.
Okay.
Pati sa badminton, yung iyong, anong tawag dito?
Cock.
Shuttlecock.
Nakinabahan ako.
Shuttlecock!
Peacock naman.
yung shuttlecock, bababa at bababa yan. Sana man hindi ko sinali yung badminton dito. And last but not the least, yung fountain. Ayan. So, kung titingnan ninyo, yung water, bumaba siya. It is because of gravity. At yung na-form niyang yan, yung pa-curve na yan, that is yung projectile.
Ay, may maganda tayong example sa half projectile mamaya. Yung
sige.
doon, yung falls, di ba nanggaling na siya sa taas?
Yes.
Naisip ko yun.
Ayan. Properties of a projectile. Meron tayong
trajectory. Meron tayong
time of flight.
Meron din tayong range.
And meron din tayong height.
Take
Isa-isahin natin
properties
yan.
of a projectile.
Yes, properties yan. Isa-isahin natin. Let's go first with the trajectory. It is the curve or parabolic path followed by the projectile. Sabi nga natin kanina, nasabi na natin, parabolic path. Ibig sabihin, parabola. Ayan, pa-curve. Okay, so it can be in full or it can be in half.
Okay, mamaya yan. Titignan natin yan mamaya.
Yes. Next naman, sorry, naunang lumabas yan. Ayan.
The combination, yan na. Tinatawag nating, for example, ma'am, example pa rin yan ng horizontal and vertical.
Yes.
Okay? Di ba yung cannonball, ma'am, kapag nirelease mo o shoot mo yan, di ba, hindi muna siya,
hindi siya agad-agad.
Hindi naman siya didiretsong nasa taas.
Yes.
Kumbaga, whether you like it or not, ma'am, bababa at bababa pa rin yan.
So, it is a combination of horizontal and vertical.
Maski gaano pa yung impact niyan, ma'am, bababa at bababa. Tinatawag na kitang mama.
Masyado naman. Mamahal mo. Bababa at bababa pa rin yan. So, una, horizontal muna siya. Tapos, bababa din yan. Yun na yung papuntang vertical.
Kasi nga, hinihila siya ng gravity.
Yes. Next. Ayan, time of flight. Pag sinabi namang time of flight, it is the total time at which the projectile stays in air. Kung gaano siya katagal nasa himpapawid. So, take note mga anak na kung gaano siya, for example, nagbato ka ng bola. 4 seconds yun bago niya ma-reach yung pinaka-highest peak niya. Ibig sabihin, 4 seconds din yung pagbaba
niya. Okay, ulitin natin. Kung nagis mo yung bola, yung na-reach niya yung pinakamataas niyang point na 4 seconds. Okay, pagbaba niyan mga anak, 4 seconds pa rin yan.
So, ibig sabihin, yung total time niya is 8 seconds.
Yes.
Kasi 4 seconds na pagtaas and another 4 seconds na pagbaba. So, 8 seconds. Yan ang ating tinatawag na time of flight. And range. Kapag range, anong pinag-uusapan?
It is the vertical. Horizontal. Sorry. It is the horizontal displacement covered by the projectile. Kung gaano layo ang narating ng bagay na hinagis mo.
Yes. So, ibig sabihin, x-axis po ang hinahanap natin dito. Kung gaano kalayo yung narating ng iyong binato. Yun. And ayun. So, take note that range, it is the longest horizontal distance covered by a projectile.
And when we say range, the maximum range is attained when the projectile is launched at an angle of 45 degrees.
Yeah, pinakamahaba na possible is makukuha niya kapag 45 degrees mo siyang hinihagis. And complementary angles result to the same range. Pag sinabi natin complementary,
90 degrees yan.
90 degrees siya kapag pinag-add.
Sum of two angles measures 90 degrees.
Yes. So, take a look at this example. Ayan. So, kapag sinabi natin complementary, 90, di ba?
Yes.
So,
ano ang complementary angle ng 15 degrees?
Yan. Kapag in-add mo siya sa 75, makakakuha ka ng 90.
Ang 15 degrees, ang ka-complementary niya is 75 degrees.
So, kung titingnan nyo,
observe mo, ma'am.
Kapag hinagis mo siya, for example, dito sa distance 30 meters, kapag yung 15, kapag naghagis ka ng isang object na ang angle ay 15 degrees, parehas ng magiging result yan sa 75 degrees. Same through with 30 and 60. 30 plus 60 is 90. Kaya kung titignan mo,
kung hinagis mo ang 30 ay napunta doon sa ating 7.5 meter, yung 60 dapat sa 7.5 meter din yan. Matik yun.
And kagaya ng sinabi kanina, pinakamalayo daw ay ang 45 degrees. So kapag hinagis mo siya dyan, dito siya mapupunta, and 90 degrees yan. 90, di ba dito? So pag hinagis mo yan, dapat dito rin siya tatama. So yun po ang sinasabi ng ating range. And last is yung ating height.
Height, it is the highest vertical distance attained by a projectile. Yan yung pinakamataas na pwedeng puntahan ng iyong binato pataas.
Yes.
Okay.
At maximum height, the vertical velocity of the projectile is 0. Bakit 0?
Kapag na-reach na niya yung pinakamataas, ma'am, ibig sabihin, titigil yun, di ba?
Di ba napansin nyo, kapag naghagis kayo ng isang bagay, kapag na-reach na yung pinakamataas niya, nag-stop siya ng konti.
Bago siya
bumaba. So, ibig sabihin, nag-stop siya, ang kanyang velocity is 0. So, take note with that. And, ayan na. Types of a projectile motion, meron tayong tinatawag na half, and meron tayong tinatawag na full. So, ang difference lang yan, paano nyo malalaman sa problem kapag half or full siya?
Yun. Kapag half, ma'am, wala siyang angle. Kapag full, meron siyang angle.
Yes. Take note, kapag half, walang involved na angle. Kapag full merong angle. Okay, here's an example. Ayan. So, ito ang example ng half projectile motion natin. Kung titignan nyo, nanggaling siya sa taas. Nanggaling siya sa taas or sa ating vertical axis. Galing na
Kunwari,
siya sa
ma'am,
taas.
may tao,
Ihuhulog
nagbato
mo.
ng bato. Pero
Pababa.
yung tao, ma'am, nasa taas.
Yes.
Okay? So, yun ang tinatawag nating half
half.
projectile motion.
Yes.
Kasi,
O yung sinasabi mo,
o
yung
yung
falls.
falls, di ba?
Galing sa
Nanggaling sa taas.
Yes.
O, wala siyang angle kasi galing siya sa taas.
Ah.
Half projectile motion siya.
Kapag naman full projectile motion, ayan, as you can see, nabilugan yan. Ibig sabihin, meron na siyang angle. Kasi nanggaling siya dito sa baba, ihahagis niya, at yung hinagis niya, bababa
siya.
because of
Kaya
the
meron na
gravity.
siyang angle.
Kaya meron na siyang angle.
Kaya siya tinatawag na full projectile motion.
Yes. And of course, ayan, here are the formula na gagamitin natin. O take note, baka mamaya malito kayo ha. We have horizontal
and vertical component.
And
take note of a half projectile motion. So, pinag-uusapan natin dito mga anak ay half projectile motion. Let's start with horizontal component. Okay? X here represents our range or ang tinatawag nating distance. So, range or distance is always equal to, okay, initial velocity times time.
Oh,
kung
sir,
bakit
may question
X yan?
ako.
Yes, what?
May question ako, bakit po yung initial velocity natin naging X na ngayon, dati 0?
Kasi ma'am, ang ating ini-emphasize dito is horizontal component.
Which is X-axis.
X represented by X. Okay.
Yes. So, don't be confused, kaya may X dyan kasi horizontal tayo. So, X-axis yan. And next, take note din na ang ating initial velocity is always equal to final velocity. Ibig sabihin, kapag ang initial velocity mo dito is 30 or 2, dapat ang final velocity mo din is 2 kasi nga equal sila.
Okay. Yan. And if you're looking for the value of the initial velocity, okay, that is always equal to the range divided by time.
I-divide mo lang yung range at time. And take note, ng acceleration ng horizontal component natin dito is constant, which is 0 meter per second squared.
Ay, pag sinabi natin constant, hindi po yan mapapalitan.
Yes. And vertical component naman, ibig sabihin, ganyan, patayo,
or
yung y-axis.
Ay height.
Yes, ang height. Ibig sabihin, y is equal to gravity times time squared all over 2. Okay. And we also have our initial velocity under vertical component. Constant din po yan. We have 0 meter per second. At kapag ang hinahanap mo naman ay final velocity
of a vertical component, that is equal to g times t. And take note that g is always constant, which is equal to 9.8 meter per squared second.
Yan po ang ating acceleration. And for time naman, same formula, meron tayo gagamitin, square root of 2y all over g. That is for both horizontal and vertical. At dahil na-explain na natin lahat, ayan, so for our examples in module number 4, of course, meron tayong in-invite na lecturer for today.
Actually, hindi natin siya in-invite, Ma'am Tintin, kasi isa siyang physics teacher din ng
physics teacher ng UPang Urdaneta.
At syempre, Ma'am Tintin, para hindi rin naman maumay, magsawa sa ating boses ang ating mga anak, tayo naman natin na iparinig ang ating kasamang nagtuturo ng physics na walang iba, kundi si Ma'am Chari
Joan Piñales. Ayan, so I hope makikinig ng maigi kay Ma'am Chari. Magkita-kita tayo ulit sa ating susunod na video discussion.
And, syempre, malapit na ang face-to-face exam.
Yes.
Let's try to use the formula by answering this problem. So, let's just read. A ping pong ball leaves at 0.60 meter high table with an initial horizontal velocity of 2.4 meter per second. Predict the time required for the ball to fall to the ground. And B, the horizontal distance between the table edges and the ball landing. Location. So, nahanap na din kung saan yung location natin nung bumaba yung bola natin. So, ang unang hinahanap is the time. Next is the distance. And the next one would be the landing location. Saan nga ba? Distance and the time. So, let's just put those numbers which are constant. Unang-una, that would be your initial velocity, the acceleration sa ating horizontal component, that is 0. Sabi ko, constant ito. Next, this one also, the initial velocity for vertical component, that is 0 meter per second. Laging 0 yan. And then this one also, ang ating acceleration sa ating vertical component, that is 9.8 meter per seconds. Yan, unahin natin yung mga constant para hindi tayo mahirapan or hindi tayo malito. Next, balikan natin yung problem natin. What are those given? We need to identify our given. So, you have here your 60 meter. So, meter high. So, high yan. So, ibig sabihin, this is your y. Yan. So, you put your y here, that is 0.60. Yan yun. 0.60 meter, yan yung given natin. And then, sabi niya, with the initial horizontal velocity. So, dito naman yun. This is your initial horizontal velocity. Yan. Ito yan. So, sabi ko kanina, the initial velocity at yung final velocity natin sa ating horizontal component is always equal. So, equal daw sila. So, yan din yung magiging value ng ating final velocity. Ano yung hinahanap natin? The time. Ito. Yung time natin. And yung ating distance. Yan. Complete natin yung table natin. Then, alamin din natin yung ating final velocity ng ating bola in a vertical component. So let's try to solve this one. Kailangan nating palabasin yung 0.84 meter. Yung ating time na 35 seconds. Paano ko yan nakuha? And then yung ating final velocity sa ating vertical component. So this is the computation for that. Let's just put this one. Yan. I have here the calculator. Let's try to use this one. So, I'm looking for the time. So, the formula for the time is 2y, a square root of 2y divided by your gravity. So, you just, wait lang po. Yan. So, meron tayong 2, and square root of 2 times the value of y, which is 0.60 meter. Yan, 60 meter. Parenthesis, and then divide by, yan ang pipindutin natin, 9.8 meter per second squared equals, and then this one. So, the value for your time is 0.35 seconds. Round off po tayo to the nearest 2 decimal places. So, ang sagot natin ay 0.35 seconds. Next, we're also looking for the distance or the range. So, we have here the value for the initial velocity na 2.4 times your time. Yung nakuha natin time doon, which is 0.35 seconds. So, the answer would be 0.84 meter. So, range yung hinahanap natin. So, meter po dapat yung ating unit. Next, what would be the final velocity ng ating object sa vertical component? So, let's try to compute that. So, you have here your value of the gravity, which is 9.8 times the value of time. This is the 0.35 seconds. Have 0.35 seconds. So, the answer would be 3.43 meter per second. Since this is a velocity, tandaan, the unit for the velocity is meter per second. Unit for the range or the distance is always meter. And then the unit for time is always seconds. Seconds for the time, meter for the distance or the range, and velocity naman, you always have your meter per seconds. Next given. We have here a soccer ball is kicked horizontally off at 22 meters high heels and land at a distance of 35 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. So, before we answer that, we need to identify again your given. So, you have here the ball kicked horizontally off at 22-meter high. So, high daw to. So, this would be your y. So, that would be your y, this one. Palitan ko yung aking ink para makita natin yung ating color. Yan, this one ba? Okay. So, sabi niya, kick horizontally off. Hindi pa rin makita. So, I'll try another color. Red siguro. And, wait lang. Gamitan natin after. So, sabi niya off at 22-meter high. High yung sinasabi niya. So, that would be your height. Yan. Next, lands at the distance of, sabi niya, 35 meters from the edge of the hill. So, distance yung tinutukoy niya. So, you're dealing about the x or your range, this one. So, meron na tayong value for the x, which is your range or the distance, and value for the height. So, we're looking for the initial horizontal velocity of the soccer. Okay? So, kailangan muna natin ilagay, sabi ko kanina, you need to put those constant numbers, which is the initial velocity for your vertical component, which is 0 meter per second. The acceleration for vertical components, 9.8 meter per second squared. And the acceleration for the horizontal component is 0 meter per second squared. So, we're looking for the initial velocity lang. Pero marami pa tayong kulang dito. Paano natin makukuha yan? Paano ko nga ba nakuha yung 16.51 meter per second? So, I'll show you how to compute that in the next slide. Ayan. So, ayan. So, first, we need to look for the time. So, sana yung aking calculator para mas madali maintindihan. Ayan. So, you have here the calculator. So, you always look for the time kasi importante yan. So, we just need this one. Square root of 2 times the value of y, which is 22 meter. Yan, 22. Yan, hindi ko na ilalagay yung, hindi mo naman pwedeng ilagay yung m sa calculator. So, 22 divide by 9.8 is equal to, and then pindutin natin ito. So, the answer would be 2.111189. So, sabi ko nga, always round off to the nearest 100 sa dalawa. So, or nearest, two decimal places tayo always. So, you have 2.12 seconds. 2.12 seconds yung ating sagot. Next, you're looking for the initial horizontal. So, meron na tayong time dito. So, makakompute na natin tong initial horizontal velocity. So, you have also the value for the x. Yan. We have the value for the x na 35 meter. Yan. Divide by your time. Ito yung nakuha natin time, which is 2.12 seconds is equal to, and then this one. So the answer would be 16.50943. So round off tayo. So 2 decimal places. So meron tayong 16.51 meter per seconds. Next, if you're looking for the final velocity sa ating vertical component, we have the value for the gravity, which is 9.8 meter per second. So 9.8 meter per second times yung ating time, 2.12 seconds. So the answer would be 20.776. So round off tayo to the 2 decimal places. So 20.78. So balikan natin. So yun yung ating nakuha dito sa ating table. Sa table natin. Yan. So makikita natin dito. So maaalala nyo, initial velocity sa ating horizontal is always equal to the final velocity. So, same yung value natin. So, this is yan yung nakuha natin kanina. Dun sa, nung nag-compute tayo. Next, we have here, let's have, yan, ayaw na naman. Yan. So, next we have here the full projectile motion. Buo na. Ano ang palatandaan natin for full projectile motion? Pag makakakita na tayo ng theta or angle. Pag meron na tayong makikitang angle. Pag may nakita na tayong angle dyan, then automatic this is a full projectile motion. So, pag nakakita tayo ng angle dun sa given natin, sa projectile motion, automatic yan. Full projectile motion po yun. Pag wala tayong nakitang angle, half lang yung ating projectile motion. So, dito din nakasalalay kung paano mo madidetermine kung half ba yun or full. Pag nakakita tayo ng angle, ulitin ko, pag may angle tayo na nakita, this is a full projectile. Pero pag walang angle, then it's a half projectile motion. Dito tayo sa ating horizontal component. So, if you're looking for the range or the distance or the x, you have your initial velocity squared sine 2 theta divided by the gravity. Pag hinahanap natin. If we're looking for the initial velocity for horizontal component, we have your velocity cosine theta. And then we have here the acceleration sa horizontal, same pa rin. This is constant. 0 pa rin yan. Meter per seconds. Yan. And then, cosine theta tayo dito sa horizontal. Dito naman sa vertical, if you're looking for the height, yan, we have here your velocity squared, yan, squared, sine squared theta, divided by 2 times the gravity. Pag hinahanap naman natin yung ating velocity sa ating vertical component, we have your velocity times sine theta. So, the acceleration for vertical component, same lang. We have the 9.8 meter per second squared. This is constant. And then, dito sa vertical component, ang ginagamit ay sine theta. Itong mga nandito sa gitna, these are their common value. So, we have here the velocity. Ito yung given na velocity na pwede mong gamitin sa ating horizontal at gagamitin sa ating vertical. So, if you're looking for the time naman, we have time is equal to 2 times the velocity sine theta divided by the gravity. If you're looking for the resultant vector, we have the square root of 2 or the velocity are the initial velocity in the horizontal component squared divided by the velocity in vertical component squared. So let's try to use the formula by answering our next slide. So here's the given. Here's the problem. Rather, a cannonball was fired with a muzzle velocity of 200 meter per second, mounted at an angle of 30 degrees above the ground. Calculate the maximum height, reach, time of flight, horizontal and vertical velocity, and the range of projectile. So, hinahanap natin yung kanyang maximum height. So, ibig sabihin, pag maximum height, this is the y. Yan. And then, time of flight. So, ibig sabihin, we're looking for the time. Horizontal and vertical velocity, this one. Your horizontal and vertical velocity. And the range of the projectile. Ma'am, paano yun? Dalawa lang naman yung given natin. Yan. Let's identify first the given. We have here the cannonball. Fire a muzzle velocity. Ito yung sinasabi ko kanina. 200 meter per second. This is the common thing between these two. The horizontal and the vertical is their velocity. So you have here, nandito yan sa gitna, this is the velocity of 200 meter per second. Yun yung given natin. At the angle of 30 degrees. So meron daw tayong angle na 30. So gagamitin mo din yan dito sa dalawang ito. So this is their common thing. So their angle and the velocity. So let's try to answer it. Let's find. First, we have here your range. Yan, meron tayong range. So the formula for the range is the velocity squared sine 2 theta divided by g, or the gravity. So, paano gawin yan? Let's have your calculator. So, meron tayong given. This is the velocity na given na para sa this is 200 times squared po yan. This is squared. So, i-square natin siya. Ito yung pipindutin natin yung may x squared dyan. Sine 2 times 30. That is your angle 30. Given yan. And then, divide by your gravity na 9.8. So, the answer would be 3,534.80. Round off tayo to the two decimal places. So, you have 3,534.80 meter. So, that would be the answer for the range. Next, if you're looking for the horizontal velocity, so you have the formula of velocity cosine theta. So, ganito naman yan. We have the given na 200 cosine 30, yung ating angle. Theta, that is the angle. So, 200 cosine 30. So, the answer would be 173.21. Round off tayo, ta? So, decimal places lagi, anak. So, we have here the 173.21 meter per second. This is a velocity. Next, looking for the height. Y. So, you have your initial, the velocity squared, sine squared, theta, divided by 2g. Ayan, paano gawin yan? So, you have here the given, which is the 200. This is the velocity. Yan yung common sa kanilang dalawa. Squared, sine, 30. Lagyan natin ng parenthesis, sine, 30. Yan, dalawa, squared. Bakit? Kasi pag ito lang po, kung ang gagawin natin ay ganito, sine 30, then lalagyan mo lang ng squared, hindi niya po makukuha yung sign dyan. So, mali yung makukuha nating sagot. So, it should be like this one. Meron tayong, yan, meron tayong 200, yan, squared, sine, parenthesis muna, sine, 30, dalawa yan, and then squared. And then, divide by 9.8, the gravity. Sorry, 2 yan. May 2 yan kasi yung formula natin, we have 2g. So, you have 2 times 9.8. So, you have here 510.20. Hindi po siya naging 21 kasi 4 po yung kasunod niya. So, I hope alam natin mag-round off. So, this is 510.20 meter. So, that would be the height for our problem. Next, we're looking for the vertical velocity. So, you have here the velocity of 200. That is the given. Your sine, 30. Also the given. Your ating angle. So, the answer would be 100. So, if you're looking for the time also, you have your 2 times the given, which is the 200, the velocity, sine 30, yan, divide by 9.8. So, the answer is 20.41 seconds. So, this is the time. So, the unit for the time is seconds. Okay po. So, next, you have here the next example. So that would be all for our day 4. See you on day 5.